All right, so welcome back. I hope that you got the side opposite of A was BC. So again, I traced angle A, and across from angle A is BC. The side adjacent to angle A, I traced angle A. Right? Angle A touches both AC and AB. We already said that this is the hypotenuse. It's not a side. And so it would be this side AB. The hypotenuse in the triangle, if you look at where the hypotenuse is, it's across from the right angle. It should be AC. The angle opposite of AB, opposite of side AB, would be across over here, which would be angle C. And then the angle adjacent to AB, AB touches both B and A. However, we said we never use this angle, it's the 90 degree, so it would be angle A. All right, so there are all sorts of special ratios that happen in right triangles. So there's two right triangles that we ask you to memorize. So the two right triangles that we ask you to memorize are the 45-45-90 and the 30-60-90. So there's special ratios and side lengths of right triangles that you must memorize, which are the 45-45-90, 1, 1, 1, root 2, and 30-60-90, 1, 1 square root 3, and 2. Now, all right triangles, though, have ratios. That all right triangles. I don't care if it's a, for example, I don't care if it's a extremely acute angle. So for example, let's call this A, B, and C, and maybe angle A is 5 degrees. If angle A is 5 degrees, then angle B will be, let's see, that's 95, so that would be 85 degrees because they have to add up to 180. There's a special ratio that happens between the short leg, the longer leg, and the hypotenuse. But we don't ask you to memorize those, right? So this is just an example. The only ones you have to memorize, again, are those 30-60-90s and those 45-45-90s. But there is a special way to find those ratios. So let's go on to an example. The tangent ratio in a right triangle is the ratio of the side opposite an angle to the side adjacent an angle. This is actually the definition of tangent. So it's not actually an example. It's the definition of tangent. Again, the tangent ratio in a right triangle is the ratio of the side opposite an angle to the side adjacent an angle. So we're going to go ahead and do an example. And I'm going to make one of our famous Pythagorean triples. We'll make this a 3, 4, 5 triangle. And we're going to call this triangle M, N, O. Now we will never use the 90-degree angle in any ratios. And these are actually called trig ratios, and we never use the 90-degree angle. Again, I talked about why. It's because across or opposite is the same as the hypotenuse, and so there's no definition for some of these items. All right, so the tangent ratio in a right triangle is the ratio of the side opposite an angle to the side adjacent an angle. So write the ratio for tangent M. All right, so if I'm at angle M, I know the tangent ratio is opposite. So opposite M is over here. And adjacent M would be, well, it's touching the hypotenuse, and this is the adjacent side. So this is our adjacent, and here is our hypotenuse. So again, first, identify opposite, adjacent, and hypotenuse. All right, once you've identified each of those, then write your ratio. Okay, so we abbreviate tangent as tan. So tangent M, I always say tangent and then what angle I'm working with, M, is equal to the opposite. The opposite in this case is 4 to the adjacent, which is 3. Again, this is opposite and this is adjacent. All right, let's do another example. So now let's go ahead and repeat this, but this time I want you to write the tangent ratio for angle N. So go ahead and pause it and see what you get. And I'm going to go ahead and do it. So we get tangent N is equal to, this time if I'm standing at N, the hypotenuse doesn't change. The hypotenuse is still the hypotenuse, but opposite is now 3. So now my opposite is 3, and my adjacent or touching angle is now 4. And so again, it's going to be opposite, which is 3, over adjacent, which is 4. So opposite, adjacent. All right, let's do another example. So example, we're going to make this a 5 and a 13, and I'm going to ask you to write the tangent ratios for the given angles. All right, we're going to name this triangle PQR, and again, we'll never be using angle Q to write our tangent ratios. So tangent R equals, and tangent P equals. All right, so first for tangent R, if I'm standing here at R, opposite would be over here, and adjacent would be right here. Now the thing is, I'm missing this side. Well, if I'm missing only one side of a right triangle, I can use the Pythagorean theorem. So I'm going to use the Pythagorean theorem first to find my missing side length. So x squared plus 5 squared equals 13 squared. Remember, this is always the hypotenuse across from the right angle, and that's always our C value. So that's 169 and 25 and x squared. We subtract 25 from each side. X squared equals 144. Square root both sides, x equals 12. Now, if you remember your Pythag triples, right, you should have known that this is a 5, 12, 13 triangle. So this is a 5, 12, 13. All right, so tangent to R will be opposite. Opposite would be 12 over adjacent. Adjacent is 5. Done. Tangent P, okay, if I'm standing at angle P, my opposite is now over here where my adjacent was, and my adjacent is now right here where my opposite was. And so this time it's going to be 5 over 12, right? Opposite over adjacent. Now, what do you notice? Any pattern that you notice? We had 5 over 12 and then 12 over 5. Here we had 4 over 3 and then 3 over 4. So do you notice that when you switch your angle, your ratio just switches? It just flip-flops. And that's it. Okay, we're going to keep going. I'm going to pause here. We'll pick it up on the next video.